fire during the show, I will run to you guys for help. Backup safety team, okay, at the back. Who knows how to use a fire extinguisher? Okay, cool. So here's your job, right? If myself or my safety team here are on fire, then we'll run to you for help. All right, cool? Don't worry, it usually doesn't happen. You should be safe, okay? Now, if you don't know how to use a fire extinguisher, right here I have a fire blanket, which is even easier to use than a fire extinguisher. You just wrap us up in this if we're on fire. It's like a little not so burny burrito, okay? Now, a little more serious though. One last thing I want to point out for this show. Science can be noisy, okay? We're going to have a lot of science demonstrations here, and some of them have some explosions and loud noises. So, I will do my best to warn you when those sounds are happening, but make sure that if you don't like those loud sounds, you have hearing protectors ready to go. You can either go like this, like this, like this. If you brought your own headphones, earphones, or earplugs or anything like that, that totally will work as well, okay? Now, the sounds are not super loud, though if you're not a big fan of them, be prepared. I will let you know, okay? How's the shuffling going? Thank you so much. High five. Boom, all right. So I'm trusting you that this is a random order. There we go. See, not an audience plant. We have no idea what it's gonna be, right? We've never met before? No, okay, cool. There we go. All right, so is everyone ready for the show?
Yes.
All right, because once I hit start on this countdown clock, we will get a 10-second practice countdown, and then, because this is a science show at the Science Museum, I will give you a little bit of science explanation for what's going to happen here, okay? So 2 minutes for a science explanation, because I won't have time to do it when the show's going, and then we'll get to our back-to-back-to-back-to-back demonstrations. Here we go.
8,
There you go.
7, 6,
Yes.
5, 4, 3, 2, 1.
Boom. Now, first thing we need to talk about before we start the show, what is matter? If you look at the stage, everywhere you look on the stage, you're seeing matter. In fact, even if you close your eyes and you're looking at the back of your eyelids, you are seeing matter. Because matter is all the stuff around us, whether it's you or me, the air we breathe, the shoes on my feet, all those things. But we can break down our matter into some pretty small chunks. Now, one of those really small chunks is called an atom. I can't show you a single atom because I have millions of atoms that make up the end of my finger here, right? So, to show you what atoms can do, we like to use the Hoberman sphere. Now, if we pretend that these green things on the outside are atoms, and we give them some energy, they spread apart. But if we cool them down, they come closer together. So if we're talking about things like solids, liquids, and gases, it's all about how far apart we have those atoms in our stuff, okay? But let's talk more about how we can change matter, okay? So 2 ways we will be changing matter in this show. I would like to demonstrate that by using a match. Here we go. Watch closely. This is a match. Is it still a match? Yes, exactly. That was a physical change. I only changed what it looked like. I didn't change its molecular structure. Okay, it is still a match. But if I go like this, now we've created a chemical change. This is something called combustion. 3 ingredients had to come together here. Fuel, which is the stick, heat, which I got from friction, and oxygen in the air as our oxidizer to keep that going. So we will be doing physical changes, changing the way things look, but keeping what they are, or we will be doing chemical changes throughout the show, like combustion, releasing energy, creating a new substance,
8, 7,
setting things on fire. Okay, cool. So I think it's time to begin. Here we go.
Here we go.
And first one is rockets. Ooh, good one to start with. Okay. So for a rocket ship, we're going to work with combustion, which means we need to blow something up, we need to burn something. For this, we're going to burn a totally unrecognizable science fuel that I have here in this container. There we go. All right. So this totally unrecognizable fuel is going to go into our rocket ship, aka bottle. But what we're going to have to learn here is the third law of motion. For every action, there's an equal and opposite. Yes. Cause an explosion on the inside, adding heat to those atoms will cause them to spread apart. They're going to come rushing up through here and hopefully send it into space. So, here we go. Adding the fuel. Now we make sure our launch pad works. We've got a spark. There's our source of heat.
10, 9, 8, 7, 6.
Here we go.
5, 4, 3,
time. Okay, perfect. Balloon pop. Okay, wow. We're really starting off with the loud ones here. Good to know. So, balloon pop requires that we work with a special ingredient called liquid nitrogen. Okay? So, liquid nitrogen is the liquid form of the gas that makes up most of the air you're breathing. If we get it down below negative 320 degrees Fahrenheit, it becomes a liquid. It cannot stay that cold. It is going to return to its gas form, which means those atoms will spread apart. So if we try to contain it with, say, like this balloon that I have over here, let's play with that balloon. Here we go. This balloon will have to grow to about 700 times its original size to contain all of that gas. So,
9, 8,
this one
7,
gets pretty scary.
6, 5, 4, 3, 2, 1.
Here's the problem. I also can't control when the balloon's going to pop, so we're going to have to move on and leave that one as we go on to cork. Here's the thing. I can't do the cork pop because it requires that container.
Oh, no.
How about that? That's interesting. We'll put that one as the next one. There we go. How about fireball? Okay, fireball. All right, so fireball. We need our lycopodium powder, which is super flammable stuff, okay? So if I were to take a bit of heat, bring it just a little too close to this lycopodium powder, no one's stopping me. Okay. Nothing happens. Okay, you probably knew that was going to happen, right? Because for combustion, we need three things. We need fuel, we need heat, and we need oxygen. This powder is so fine that we can't get enough oxygen to those grains. But if I were to...
Okay.
10, 9, 8.
But if I spread it apart, you get a nice fireball.
Cheers.
2, 1.
Okay. And now we can do, where's that cork pop? There we go. Now we can do cork pop. Okay. So for cork pop, we're going to see the same sort of thing we saw with our balloon pop, but we're not going to work with something as loud or scary. We are just going to add some corks to the top of this container. So here we go. We saw how the pressure can be really dangerous. So let's add a little bit more nitrogen to that one. There we go. And let's try to force some corks on top of this container. Here we go. This is one of the more interactive parts of the show. Sometimes they escape. Now you'll see that, oh, there we go. Ooh. The pressure from that nitrogen expanding is extremely dangerous. There we go. It attacks me. Okay, here we go. So, pretty scary stuff.
9, 8, 7, 6, 5, 4, 3,
Here we go.
2, 1.
Okay. Next one we have cloud. Ooh, okay, cool. So, using all of our liquid nitrogen for this one. Stay. Okay. So far, we have seen nitrogen expanding, but we need to play with this nitrogen cooling other stuff down. Since we know it's extremely cold, what I want to do is talk a little bit about the weather, okay? So we're going to add all of my nitrogen to this bucket, and then I'm going to add some really hot water to another bucket. All right, here we go. So when water evaporates or boils off, it rises into the air as water vapor, condenses up there in the atmosphere, and turns into our cloud. So if we were to cool it down here on stage, we could create a massive cloud with all of that water vapor.
10,
So here we go.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay. Whew. All right, next one is boom balloon. Oh, that felt good. Okay. All right. So boom balloon, we're going to work with a really dangerous gas here called hydrogen. All right, now